I'm Ben. I work at Mode. We build a BI and analytics product. Also, as Sean said, if this is stuff you're interested in, I yell a lot at the internet about these sorts of things. When I first submitted this talk 6 months ago or so for the first round of data council that didn't happen, this is what I submitted. And so the sort of story that goes through with this talk is I was going to talk about what is an OLAP Cube. I was going to talk about why they went away. I was going to talk about why they came back. And I was going to say it's like a pretty good reboot. This is a good thing. We should be excited about OLAP Cube coming back. I felt pretty good about this story, but then over the course of the next 6 months, it turns out I didn't feel so good about the story. I talked to some people. They actually did change my mind. So it turns out that's not the story I want to tell. Oops. So the new story I'm going to talk about is what is an OLAP Cube, why they went away, why they came back, and why it's not such a good reboot, and why this is actually a thing that we should be a little bit worried about. So that's sort of the story of what this is. To start off, what's an OLAP Cube? If you want to know what an OLAP Cube is, I would recommend you reading this blog post by Claire Carroll. This is the blog post. It goes into very accessible detail about what an OLAP Cube actually is. The short answer of this, of what is an OLAP Cube, is it's a table. All it is a table structured in a very particular way. It's easy to think of these things as like something fancy and some special technology and things like that. In reality, it's just a table used for a particular thing. And so to explain that, I want to use the context of imagining that you work at Lego. This is Lego's headquarters, which is a cool office. I didn't know this until I started digging up pictures for this. So suppose you work at Lego, and you're like some big boss man at Lego, and so you want to figure out how people are actually buying Legos. And suppose also this is in the 90s because you're using OLAP cubes, and that's when OLAP cubes were popular. So how would you actually answer questions about whether or not people are buying Legos and where they're buying them and those sorts of things? You could imagine you would have a bunch of questions. You'd have questions like, how much money do we make in California? How much money do we make in Ohio? How much money do we make in Ohio in January? All these sort of basic business reporting questions that would be the sort of things you need to make decisions. To answer these questions, Lego probably has, or hopefully has, a big log of all of the times that people buy Legos. So they've got this big table. This is a straightforward table to understand. It's one row per purchase, and it's got some details about the purchase, like the item and the store and the state and how much it cost and all those sorts of things. These prices seem way low for how much Legos cost. And so this is how you would actually do this sort of reporting. So the problem here, though, is Lego sells a lot of Legos. According to this random PDF that I found on the internet called The Art of the Brick, one of the quirky facts about Legos is that they sell 7 a second. These are the best 7 Legos that were made before 2000. This is a stand I will take here. So they sell 7 a second. So if you do the math, that's 200 million or so Legos a year. And so if you are asking questions like these in the 90s on top of 200 million or so transactions, that's going to take a really long time. Databases could not handle that well, certainly couldn't handle it that well if you're running it on your local computer, trying to put it in something like Excel. That doesn't work. You can't actually do a bunch of math on top of records that large in computers of that age. So what do you do instead? What they would do is instead of saying we're going to compute it directly on top of this raw transaction log, we will instead create an OLAP cube. And so an OLAP cube is a roll-up of that data aggregated by different dimensions that you actually want to look at it with. And so there are kind of 2 sections to this thing. The left side in blue are what are called dimensions. These are basically groupings that you could say, okay, we want to look at it transactions by month. We want to look at them by state. You could imagine other things here as well. And then the green part of this is measures. And so these are metrics. These are how much did we sell, the number of items, those sorts of things. And so what you can do with this is, now you can actually roll this up again. You can basically turn this into a pivot table and compute the sort of questions that were being asked by the Lego dude earlier. So if you want to look at, say, the number of the average sales by state, you can pretty easily pivot this table around to get average sales by state. If you want to look at the total sales by state, same thing. If you want to look at sales by month, you can do that. Or you can create fancier pivots that are kind of computing the same stuff. And so the idea here is now to be able to run these things, it's way faster because you're not having to run all of these calculations on top of that 200 million row table. So sort of graphically how that looks, you've got this raw data. You now have an OLAP cube that pre-aggregates this data into this nice condensed form. And then when you want to do reporting, you aggregate it again to be able to actually aggregate to the metrics that you want. And when you do that, it's just a loop between the reporting layer and the OLAP cube itself, that you never actually have to go back to the 200 million rows. So there's some benefits to this. One of those is you can now ask a bunch of questions quickly. And when you think about like the point of business analytics, you think about what people are trying to do when they're trying to make decisions with this stuff, they want to be able to iterate through these questions. And so it's important to be able to not take 10 minutes for each one of these things to come back. And so now you can actually do that quickly. There's another benefit to this too, which is this thing actually is consistent. So for anybody who's actually tried to do business reporting, you probably realize like it's difficult to actually make metrics consistent. They get sort of created in a bunch of different places. By using an OLAP cube, you basically compute those things once and then build a bunch of reports on top of the intermediate OLAP cube. And so now you have consistently calculated metrics. There's one big downside though, and if you like read anything about OLAP cubes, it will very much point these things out, which is you have to pre-compute everything. Like you don't actually have access to this raw data anymore. You only have access to this intermediate step. And that requires you to actually pre-compute it and kind of predefine the questions you want to ask. And so you're pretty limited in what you can do here. And so by way of example, this was the original OLAP cube that I showed you. It's, I don't know, it's like what, 12 rows long. It's got only 2 dimensions and 1 measure. You might add other measures, so you might add the number of items sold, or you might add like the total tax paid or whatever else. These things don't actually add that much. Like this cube's not getting that much bigger by just adding it out horizontally. You're not actually adding new rows. But if you add new dimensions, it becomes this kind of like combinatorial explosion where each one of those things you have to recompute like the entire, each possible aggregation. And so if you want to add the store ID for where these Legos were purchased, you can see this table starts to blow up. And so to get a sense of how big this actually can get, in 1999, I did some more digging on Lego history, there were 4,597 total Lego sets that you could buy. If they sold those in 50 states across 52 weeks, then this actually comes out to close to 12 million possible combinations. And so just reporting across 3 dimensions and only the time granularity of week and only like the location granularity of state, you actually probably can't do much on top of this in something like Excel in that age. So again, very slow. So that's really like the constraint of what an OLAP cube is you can't put that much in it because these things can blow up really fast. But they provide these other benefits. So to kind of summarize that, people can answer questions quickly with them, metrics computed consistently, everything has to be pre-computed. There's actually no, like a second problem here that people don't often talk about OLAP cubes, which kind of is part of the reason you have to answer the question of like, what is an OLAP cube? And that's that OLAP cubes are actually really unintuitive to use. That they aren't something that make a lot of sense to people who are trying to consume them. They might make sense sort of in the way that you're trying to use them here, but they don't actually make sense as a way to distribute data to other people around an organization. So to explain that again, using another Lego example, imagine that you're like in a board meeting, somebody's trying to ask a bunch of questions, you're putting together reports for sort of this basic business reporting, like open bugs or whatever they have on that whiteboard. The kinds of questions that people are going to ask for this sort of thing, for this kind of reporting, are going to be structured like this. They're going to be like, how many bricks did we sell? What is our revenue? And they may get more detailed than this. They may be, what is our revenue by week, by the set theme in Europe? Like they will be these sort of different drill downs into this number. But fundamentally, what this question is about a metric. It's about this metric at the top. And sort of in this sentence, in all of these sentences about how people are asking questions, the metric is the object of the sentence. And this is like, I'm from the South. We didn't diagram sentences in the South. This is my attempt to diagram a sentence. I think that's like the, I don't know. You get the idea. I put it in bold. So like the metric is the object of this thing. And so that is the question that people are asking is, they're saying, get me a metric. Like that is the fundamental thing that they want. And there's a bunch of stuff that's underneath metrics. There's like tables, there's different logic, there's different like sources of where that data comes from. People don't actually care about that. They're not trying to track that down. What they're trying to track down is how do we define this metric? Give me the metric as I understand it. And so while data teams have to worry about all this stuff, the people who are trying to use it and the people who are trying to use the OLAP cube really only care about the thing at the top. So this is the first form of question. The second form of question is, say in the course of this board meeting, people say, hey, I think we should open more Lego stores. And so now people are trying to ask questions of like, how are Lego stores performing? It's kind of this open-ended exploratory question. So you want to look up basically what's happening in Lego stores. And then the question that people start asking is, I want a list of stores. I want some data that I can explore. But the way that they ask these questions is, I want a table. I want something that's just a list of objects. So give me a list of stores. And again, you may get more detail about this. There may be things like with details about their location or hours or data about their sales and operating and things like that. But the point again with this is like the noun in this sentence is still the list of stores. And so what they're asking for is a table where each row is some object that they can understand. Like they want to be able to look at a table and say, oh, each one of these rows is a store. There's a bunch of dimensions and sort of measures about these stores, but I can understand conceptually what each row is. Like it's a very consumable way to look at data, and so this is typically what people are actually asking for. They're saying, get me a list of stuff, and I want like to understand what that stuff is. This is where OLAP cubes run into a problem, which is this table is not a table of anything. Like it's very hard to actually describe what you're looking at here, because it's kind of a list of objects, but not really, because it's kind of this like combinatorial abstraction where it's like kind of a state, but not really. It's kind of a month, but not really. If you had stores, it's kind of stores, but not really. It's also not really a list of metrics. Like metrics are included, but to actually be able to compute like revenue, you got to recompute it again. It's all broken apart. It's very hard to describe to somebody what this thing actually is. If somebody asks for data and you send them this, it's like, I don't really know what to do with that. Like it's a difficult thing to actually make sense of. And so the reason this becomes a problem is we build a lot of UIs on top of this that basically display UIs like this. And so this is an old BI tool. It's a modern version of it. This is, I believe it's MicroStrategy. And you can see on the left, these are like the sidebar of fields. This is the way that this data gets presented to users, is via these sidebars of fields. And if you want to understand what you're doing here, like the way people conceptualize this is, they typically imagine that there's a table underneath this, and like, how am I manipulating that table? But if you look at these fields, it's really hard to actually understand. Like, it doesn't really make sense what's underneath this. The fields here are things like, I can't even read that, it's things like customer, day, item, metric. Like, what table would have like columns like this? Doesn't really make sense of like what the table underneath this actually looks like. Similarly, there's some metrics like gross margins, but there's also metrics that are average price per unit, last year margin. Like it doesn't, in looking at this, if you're just playing around with this as someone who doesn't understand sort of the structure underneath it, it's hard to understand what you're actually using here. That you drag and drop a bunch of fields into a chart, but like, what is that being computed on top of? The way we think about data is tables, and there's not really a table here. There's like a hint of a table, but it's not actually a table. And so I think that's one of the reasons that this gets so complicated for people to actually use tools like this, is it's not the way that we think about data. It's not intuitive to think about data in this structure. There's another one down there that's order count. So what happens with OLAP cubes is these things are really hard to understand, and yet this is the way that we typically ship data to people when they're trying to do like BI work, is we say, here's an OLAP cube with some UI abstraction on top, and people have to kind of understand that data structure, and it's fundamentally a data structure that doesn't make a whole lot of sense. So people may be saying like, okay, cool, OLAP cubes, great. This was a thing from a long time ago. We've gotten rid of them. And to some extent, that is true. Like 10 years ago, Redshift came out. We now have things like BigQuery. We have things like Snowflake. Today, to be able to compute data on, or like metrics on top of 12 million rows, these databases can do that very easily. They can also do that on top of 200 million rows very easily. So in a lot of ways, like we don't actually need to pre-compute anything anymore. There's not a need for this intermediate step to improve the performance of how quickly these things are running. And so what that leaves us with is, we have a world that looks like this. We can just cross this off. We say, actually, we don't need this. That we can now do on-the-fly queries directly against the database without having to worry about this intermediate step. And so this is like what things that happened 10 years ago. We got rid of OLAP cubes. We have this chart, like they went away. Great, no more OLAP cubes. Why are we even talking about this? We got rid of OLAP cubes as this like materialized structure, as a thing where we actually run the computation to compute that cube. But we didn't get rid of them in concept. And so one of the more modern BI tools that like sort of initially pioneered this idea of like a no OLAP cube BI tool is Looker. And so if you think about what Looker does, it doesn't actually get rid of the OLAP cube. It just sort of does the computation in a different way. And so if Looker, the way Looker works, for those who don't know, is you've got raw data. So same as before. Rather than defining an OLAP cube, you write this configuration language called lookml that defines the relationships between tables in your database. So it says, hey, you should join customers to purchases in this way. You can aggregate these various like sales numbers up in this way to compute a revenue metric, those sorts of things. When you define this in LookML, what happens then is that creates a UI in Looker's product that lets people pick and choose these various metrics. And when people choose them in this drag and drop UI, that gets passed back to the data model, which generates a SQL query on the fly. And then that SQL query is run against the database. So rather than running it against this intermediate step of pre-computed data, Looker is just passing the whole thing through back to the database. And then you get your results back as you would in a classic BI tool. But if you look at this, the way this actually works is very similar to what an OLAP Cube does. That there is this definition in the middle that says, hey, here's how we want to aggregate this data up. Here's how we're going to actually do this reporting on it. You get a UI out of it, and that UI is the thing that gets presented to people to actually use it. And then there's like this transaction back and forth between the reporting layer and the data model that says this is how we're actually going to use it. So there isn't an OLAP Cube here in a traditional sense, but what LookML effectively is like a synthetic OLAP Cube. It's an OLAP Cube that doesn't get materialized, but it operates in very much the same way. And so like this structure is kind of the same. That it's true, it's not materialized, but it's still like, fundamentally the same architecture as what we had before. It's just the query to generate the OLAP Cube happens on the fly instead of happening like prior to people actually doing all of this reporting. And we see this all over the place. So BI tools and analytics tools all use this architecture in some form or another. If you look at Tableau, Tableau has Tableau extracts, which are very similar to what LookML is doing. It's defined in kind of a different way, but you're defining ways to actually aggregate and join data together. When you do this extract, that builds a Tableau UI where it has these same fields on the left side. So this, too, kind of very similar structure. You've got the extract in the middle, and then you've got the drag and drop UI on the right. Even Mode as a product does something similar. So the way that we do this is you can write a SQL query on the fly. That SQL query then gets loaded into an intermediate data store where we put charts on top where you can drag and drop. So again, kind of a similar structure as traditional OLAP cubes. Even some of the more modern stuff, so metrics layer tools like Transform, also do something that kind of looks like this. So the way Transform works, you define a bunch of metrics in the Transform like metrics definition language, and then you're able to actually interact with that through code or through other interfaces, but you're, again, interacting with this through the kind of modeled layer that Transform provides. And so, again, you end up with a very similar structure. What happens now, because we've kind of mirrored this OLAP structure, we've mirrored this concept of like, hey, we define data up front, that creates a UI, it creates a way to interact with it, is we've ended up shipping that structure to users over and over and over again. And so to quote the same quote that got quoted in the keynote this morning, this is a paraphrased version of Conways Law, which is basically saying you ship your org chart. There's a corollary to that, which is like you ship your architecture. The product experiences that people have is a reflection of the architecture underneath it. And if we are consistently using an OLAP Cube architecture, even if that architecture isn't like actually materializing the OLAP Cube, but is one that uses the same concepts. It uses these dimension and measures concepts. It uses this kind of idea of pre-aggregating data, whether or not it happens on the fly or whether or not it happens beforehand, to actually present the UI to users. We end up shipping the same kind of UI that we see here, which is a very confusing one for folks if you don't understand that underlying piece. And so you actually see this, again, reflected all over the place, where you see it in Looker's UI. They have something very similar, broken up again by dimension and measures. You see it in Tableau's UI. You see it in Node's UI. You even see it in the Transform query language, where it references the same concepts. And so like over and over and over again, we are using this same concept, which is fundamentally a confusing one for the people who it's meant to serve. And so like the reason for that is this. The reason for that is that we define these UIs based on the technical architecture underneath it. That we say, okay, OLAP cubes make sense. They do make sense for a lot of reasons, but we then end up shipping the way that it's actually built for the way it's actually consumed. And the way that we should do this, instead, if we're thinking about like the way we actually want to serve the people who are doing the analysis and reporting, is go the other direction. We should think about like what it is that these people want, how is it that they actually consume data, and then make sure we're reflecting those experiences back on the OLAP cube rather than taking the OLAP cube and reflecting it back to the end user. And so what does that look like? The ways that we should be doing this is the same concepts I talked about before. These people think about metrics. These people think about data sets or like a list of things. And so we should be reflecting those experiences back through the OLAP Cube rather than this kind of abstract version of it that is the thing that we've actually built. So for a final example of what I think this looks like, I'll go back to the one bit of my personal job history that Sean didn't mention, which is I used to work at this think tank in DC. They got some work to do this year, I guess. So I did a bunch of economic research. And so my job was to basically write reports about what was going on in the global economy at the time. That was in 2009, so it was also a disaster. And so I had to work with a bunch of government data sources. And if anybody's ever worked with government data sources, there are some that you learn to love and some that you learn to hate. There were two that I really liked and one that was terrible. One of the ones I really liked was this one. It's the St. Louis Fed. It's the Federal Reserve data from St. Louis, or the St. Louis Fed's data. It's the kind of canonical place to look up a bunch of economic data in the US. The reason I really like it, the reason it's really easy to use, is it presents this data as just metrics. It just says, hey, here's a whole bunch of different metrics that you might want to look at. Like in this case, it's got Treasury maturity yields, it's got federal funds rate, it's got 30,000 other ones, whatever the number says on the side. But these things are organized just as a metric. I don't have to think about how to actually create this. I just look up the thing I want to define. If I want to find unemployment rate, I just look it up, I find the table, I look at it, it shows me a graph. It's super easy to use. The other government data source I really liked was this one. This is a screenshot of this from 2019. I don't know how this is still actually up in 2019. This is from the IMF. So the IMF provides a bunch of data about economic indicators across countries. The way that they provide this data is you choose countries or regions, you click a bunch of checkboxes, it shows you those metrics by those countries. It gives you a table where each row is a country. It's very straightforward to understand. So this data is great. The data from the St. Louis Fed is great because they are organized by data sets or they are organized by metrics. And that's a very consumable thing. And so in this point too, I was also someone who never learned SQL. I was familiar with Excel. I'd attempted to use R, but not very well. That was the way that I understood data, and that's pretty representative of what a lot of people who are using BI tools are trying to do. That's the level of technical expertise most folks have. And the thing that made sense to me and the things that make sense to them is a set of tables that I can understand what each row means, and a set of metrics where I don't have to choose how to actually calculate it. The website that I actually hated was the census. This is actually the modern version of this. If anybody else tried to look at this in 2010, it was something called the Data Ferret. It was an absolute nightmare. If you know about that, you know about it. I have no idea how to use this thing. This is effectively an OLAP Cube underneath it, but it's got this data sets on the left, but you can choose different sort of filters, and there's these fields on the far left, and you can pivot it in weird ways. And it's more flexible, I guess, but it's, again, presenting this concept of an OLAP Cube back at me rather than just saying, I want to find some metrics about unemployment rate by state or by income by different geos. I can't actually do that. I have to kind of think about what the underlying data structure is for me to make any sense of it. And so I didn't. And so I avoided this as much as I possibly could. And then they usually give you a bunch of things. You have to download micro data files, and it was a nightmare. So this is the way, though, that BI tools typically present data. They use this model rather than the previous two. And so that means because we have OLAP cubes, whether or not they're in the old form or whether or not they're in more modern form, we end up with this kind of amalgamation of metrics and data sets that doesn't really make sense. It tries to be both in one. Technically, it's probably more flexible, but it's really hard to use, and it's what drives a lot of people to not be able to make sense of the data they're looking at in their BI tools or analytics tools. A better option would be to split it. Would be to say, hey, there are different types of ways of looking at data. Rather than trying to collapse this thing into one, let's present it in the ways that people actually understand it. Present some as metrics, present data sets, allow people to split this up. It may not seem as clean. We may not have this sort of perfect sense that everything is all this nice one package, but that's not how people think about it. When people are thinking about data, they're not thinking about it all as one thing. They're thinking about it as, hey, I need to look at a metric, or I need to find a table for a data set, a table to explore. So after thinking about all this, the place that I now ended up was return of OLAP cubes is troubling. This is now the stance that I guess I have until the next time that this talk comes up, in which case I guess I'll feel differently. But I'll stop there. If folks have questions, that's all I got.